Hi everyone, welcome to Gateway Lectures. Here we have a good question in thermodynamics. Let's see the question. The reading TA and TB of two centigrade scale thermometers A and B graded at ice point 0 degrees centigrade and steam point 100 degrees centigrade. Because when it is said it is a centigrade scale, it should always be graded between the ice point and steam point because they need two reference points here. For this type of thermometers, which were invented before 1954. For these thermometers, we used to have two reference points. They are ice point and steam point, and the values are given as 0 degrees centigrade and 100 degrees centigrade are related by equation. So the two thermometers are related by equation. Actually, when the two thermometers are made of a same substance, like same build material and also the same thermometric fluid used or thermometric material used, they need not have any relation. They will be reading same value for each whatever be the temperature. But here A and B are two different centigrade scale thermometers. Maybe A is made of some material and B is made of some material, and the relation among the temperatures is given as TA is equal to L plus MTB plus NTB square, where L and M are constants. They are constant for the relation. When both are immersed in oil, the thermometer A reads 51 degrees centigrade and thermometer B reads 50 degrees centigrade. Okay. Since their material of construction is different, when they are immersed in the same oil, they read different temperatures. Determine the reading on temperature A when the temperature B reads 25 degrees centigrade. Also comment when thermometer is correct. So which thermometer will be correct? Actually, we need to define which thermometer will be correct. At last, we'll be knowing this meaning. What is the which thermometer is correct? Let's go through the solution. And going to the solution, first of all we'll write the given equation. According to given equation, T is equal to L plus MTB plus NTB square, right? And we need to know the values of L, M and N. Here we have three constants, so we need three useful equations here. So the first equation or the first condition will be both the ice points were same. So when TA reads 0 degrees centigrade, the TB also reads 0 degrees centigrade. Okay. From that we'll get to know 0 is equal to, substitute T and TB in the equation, L plus M into 0 plus N into 0 square. From that we'll get the value of L is 0. So one constant was solved. For solving the next constant, we take the condition 2. The condition 2 is, this is ice point condition, and the other is the steam point condition. Because the centigrade scale at ice and steam point, they are calibrated at same values. When TA is 100 degrees centigrade, TB reads 100 degrees centigrade. From that, 100 is equal to, L is 0, so no need to write L. M into 100 plus N into 100 square. Okay. From here we can get an equation, M plus 100N is equal to 1. This is a one condition among M and N. Let this be equation 1. Next, two condition was finished. There were actually three constants. We need to take the third condition. Condition 3 is given when it is immersed in an oil. So when it is immersed in an oil, TA reads 51 degrees centigrade and TB reads 50 degrees centigrade. Substitute the values in the equation. 51 is equal to L is 0, M is unknown, into 50 plus N into 50 into 50. Or we can add just 2500, but here we need a small simplification. Bring the 50 to the LHS. 51 by 50 is equal to make the equation simple so that it is easy to calculate. And this is the second condition we've got. So by solving the equation 1 and equation 2, okay, when we solve the equation 1 and equation 2 on the calculator, we get, here we use a calculator because this will be a descriptive type question. So M is equal to 1.04 and N value will be minus 4 into 10 power minus 4, right? And here they finally asked, determine the reading of temperature A. See here all L, M, N and every value is known. Determine the reading of the temperature A when the temperature B reads 25 degrees centigrade. Sorry, 25 degrees centigrade. Then the TA value will be equal to, we use the same equation. TA is equal to, L value is 0 plus M value is 1.04 into TB plus of minus 4 into 10 power minus 4 into TB square. Substitute all the values, we get TA value. TA is equal to 1.04 into 25 minus 4 into 10 power minus 4 into TB square. 25 square is 625 and from that, by solving this, we got the TA value as 25.75 degrees centigrade. This is the value of TA. Right, the actual question was finished. This is the answer, but also they've said also comment which thermometer is correct. For that, if you can observe the readings of TA and TB, at ice point they read the same, 0 degrees centigrade, 0 degrees centigrade, and also at steam point they read the same, 100 degrees centigrade, 100 degrees centigrade. But the only difference is, suppose between 0 and 100, it was divided into 100 parts, let's suppose, then each degree centigrade will be a unit part, right? But if in TB it is not a rule that it should be divided into single division. It can be divided into many multiple divisions depending upon the adjustability of the thermometer, because depending upon the arbitrary nature. So these thermometers are arbitrary thermometers, both are centigrade, but these are arbitrary thermometers. We can take depending, suppose in few applications we need to calculate only integer values, 25 degrees centigrade, 30 degrees centigrade, 31 degrees centigrade, in that way. Then we use 1 degree unit, 1 degree centigrade as an unit, and we make that 0 to 100 as 100 divisions. Suppose in some applications we need to calculate at 25.5, 26.7, 30.2. So when we need multiple integral values, then we need to divide the temperature scale into still very minute divisions, so that we can get the decimal values also. So in these two thermometers are calibrated in the same way, and when TA reads 0 degrees centigrade, TB also 0, 100 and 100 both were same. But when TA reads 51 degrees centigrade, this reads 50 degrees centigrade. Similarly, when this reads 25 degrees centigrade, this reads 25.75 degrees centigrade. From here we can observe this is divided into 100 divisions, since we are getting all the integer values. Here it is divided into more than 100 degrees centigrade. So both the thermometers were correct. So in question it was asked also comment which thermometer is correct. Actually both the thermometers are correct. They are arbitrary in nature. So both the thermometers are correct. Both the thermometers are correct. They are arbitrary. They are arbitrary in nature. Right. Thank you for watching this.